Hello everyone. So now we're going to solve numerical from the kinematics portion of the Irodov. Okay. So this is a numerical 1.1. So what the numerical says, let's see. The numerical says that a motorboat going downstream overcame a raft at a point A. Okay. The time is 60 minutes. Later, it turned back and after some time passed the raft at a distance L equals to 6 km from the point A. Find the flow velocity assuming the duty of the engine to be constant. So here it is being asked that we need to find the velocity. Flow velocity means the river velocity. The river velocity. You need to find the flow velocity or the river velocity. Okay. Or the raft velocity. Because you know that raft doesn't have its own engine. Okay. So it follows according to the velocity of the river, that is downstream or upstream, whatever it is. Okay. So these are the things we need to find in the numerical. So let us start solving it. So let me change the pen. Okay. So this is a solution here. I'm making it. Suppose this is okay. This is a river here. I'm drawing here. This is a river, and this is boat here. This is the boat. Okay. This is suppose that is having its own engine. It's a motorboat. Okay. So it's suppose that its velocity of going velocity is basically v. Okay. And there is a raft. Make it with this color. So this is a raft. I did not colors. So this is a raft basically. Okay. So this is basically a raft. Okay, this is a raft. So what happens is that at a point, given in the question is that what happens is at a point A, suppose this is point A. Okay, so at point A, what happens is this boat overcomes the raft at point A. Okay, here. So then t equals to 60 minutes later, tau equals to 60 minutes later turned back. Okay, so after traveling for 60 minutes, suppose from here to here it traveled, and the time it took was 60 minutes. Okay, so after from here, let me see that this one. So this is a motorboat, and this is like this. So it turned back from here. So let's make a diagram of turning back. So it turned back. Okay, and after some time passes the raft at a distance L equals to 6 km from the point A. Okay, so it's common, you know, when the boat from the boat after overcoming the raft at point A, it travels for the 60 minutes, and then after some time it turns back and meets the raft at a distance equals to L equals to 6 km. So this distance, say this distance is equals to L equals to 6 km. Okay, so it's obvious that if the boat travels for the time 60 minutes plus 60 plus t means it's because after some time, no. So 60 plus t minutes it meets the raft at L equals 6 km. The raft obviously it would have been, you know, traveled some distance in the time in which the boat is moving. So the boat after moving met the raft at this point, B point. Okay, this was a meeting point. So total distance is 6 km. Yeah, so this is the boat's meeting point with the raft. I have drawn it here. Okay, so this is basically the problem which I have drawn here. This is basically the problem. So for making it more convenient, let's solve it. Let's make a simple drawing here. So this is point A. Okay, this is point B, and the distance between both the points is L equals to 6 km. Okay, and this is the meeting point of, this is raft, meeting point of raft. Okay, this is raft basically, meeting point of raft, and this boat, this is basically boat, this is boat. So this is the meeting point of raft and boat. Okay, so now what we're going to do is we are asked to find the river velocity. We're asked to find the river velocity. So how are we going to find it? It's easy. We're going to use here relative concept. we are going to use here the relative concept. That is a relative concept, relative motion, okay, for the solution. So let's start solving it. Uh, we know that since the board took 60 minutes, okay, after 60 minutes means that it's like that 60 minutes, then it took after some, see this here, we said that tau equals to 60 minutes later, it turned back and after some time, so it's 60 plus some after some time, means that 60 plus some t, okay. So we write here 60 plus t, this is the time total taken by the bot, okay, and then it moved backward. This is the total time when there was a meeting point of this raft and the boat, okay. So what happened in this case, what if we see on, if we sit on the this frame of reference of the raft, okay, suppose we take the raft, look the raft here, suppose this is a raft, okay, suppose this is a raft, suppose this is a raft. If we sit on the, so if we sit on the frame of reference of the raft, okay, so then we will see that actually the boat, what happened is actually the boat moved, okay, then it comes back. So we will be seeing that, you know, that we are still in the boat moved and it come back, okay. So the total time it took was 60 plus t. So converted into r, we said at 1 plus t, because the t value which will come is basically uh, t value is basically we need to find here, okay. So it's common that the time it took for moving away and the time it took for coming back was same. How we can conclude this? This is because, you know, as it took as the boat first was going downstream, so it took t equals to 1 hour, okay. So now when it's coming back, it will take the same time according to relative concept if we sit on the frame of reference of the raft. But if we are sitting, if we are on the ground frame, so the ground frame we will not see this. So the ground frame it will be something different. That's a different case. But in the relative concept, if we sit on the raft, then on the frame of the reference of the raft, the thing is that it will take the same time. The boat will take the same time. Why? Because since the raft will have the velocity of, raft is moving with the velocity of the river velocity, because it's not having its own engine, okay. So what is the speed of the river will be, what the speed of the water will be, so it will be the same, will be this case for this, same with the speed of the raft. So when we are on this frame, so the river has stopped, the raft has stopped, okay, simultaneously. So what's going to happen is that only the duty engine which was working, means that if it was moving with v speed downstream, so it will move this with the particular speed v only. And if it took the time, if it took that this time, then it will again take the same time only, okay. So the total time will be for 60 minutes, that is 1 hour, then t will be also equals to 1 hour. So total 2t equals to 2 hour, okay. So this is the total time. So what's going to happen is that the raft person will see that the boat moved for 2 hours and it come back, okay. So this fill with observation if we are on the frame of reference of the raft. So the total time it took was 2 hours, okay. So meanwhile what happened, we see that meanwhile we have seen this the boat moved, the raft moved 6 kilometers, okay, because that's the meeting point of this boat and raft. No, there's a meeting point of this boat and the raft. Where is that? Yeah, this meeting point of the boat and the raft. So total time it took was 2 hours, according to observation of the frame of reference of the raft, and distance with the raft moved meanwhile we observed that 6 kilometers, okay. So 6 kilometers is distance and the time is 2 hours, okay. So which through this we will get the velocity of the river. So what's the velocity of the river? It's 2, sorry, we will get the velocity of the raft, okay. So this is 3. This is the velocity of the raft, which we know that is same for velocity of the river, okay, which we know that this is same for velocity of the river, because raft doesn't has its engine, it moves according to the speed of the river, the speed of the water downstream or upstream. So velocity of river is equals to 3 kilometer per hour. This is the answer, okay. Also we have a case of solving it downstream, which is far much better than this, logically far much better, but through this relative concept we'll get the answer very easily, okay. So let us solve it from the ground frame. Solve it from the ground frame. From a ground frame, I will make it for both the observations different for, you know, according to the boat and for the raft from the ground frame. First take us for the boat. Suppose this is a boat, okay? From point A, it started, means that it overcame the raft, and then it moved for 60 minutes. Tau equals to 60 minutes, or say the tau equals to 1 hour. Then it turned back, okay, this boat turned back, and then after some time, means that say T, it again made the raft, which is here. Now let me make it. This is the different colors. This is the raft, okay? This was a raft. So it made it here. So the meanwhile time in which the boat, traveled for the 60 minutes and turned back, and after some time made the raft at point B. So the total distance in the meanwhile time which the raft has traveled, at that time it has traveled, was 6 kilometers. Okay. So this is 6 kilometers the total distance. So now what we're going to do is that we'll make the equations basically. Suppose that the river velocity is r, which will be the same velocity for the, I'm sorry. Suppose the river velocity is v, which will be the same velocity for the raft, okay? Because you know this, that's, as a raft has not its engine, so it follows the speed of the river, the water, okay? And suppose that we have boat's velocity is equals to vb, okay? This is the boat velocity vb, means engine velocity vb, okay? So while going in this direction means downstream, the velocity of the river will add. So what gonna, the total net velocity will be vb plus v. This will be the net velocity for the downstream for boat from the ground frame observation, okay? This is g frame, this is ground frame, and the time it took was, complete time it took was 1 hour, okay? So 1 hour for downstream and going, then it turned back, and after some time met the boat, the raft at 6 kilometer distance. So basically if we say that this distance will be this total net velocity vb plus v into time, which is 1 hour, okay? And if we minus this distance, let me mark it with red or pink, say. If you minus this distance, then we'll get the 6 kilometers. It's fine. So vb plus v into 1 hour will give us this complete distance. Then minus, if we subtract this distance from it, we will get this net distance, which is 6 kilometers, okay? So vb plus v minus, for the upstream, it will be vb, boat's velocity, minus river velocity. Okay, we are considering that the boat's velocity is, it's common sense. vb will be greater than v only, otherwise how it will motion towards upstream. So pv minus v into time is equals to basically, this is all the case, vb plus v equals to 1 minus vb minus v into time. This will give us a distance which equals to 6 kilometers. Okay, so now let us solve it. vb plus v minus vbt plus vt, vbt plus vt equals to 6 kilometer. Okay, so this we got here. Now from here we can see this. One thing is that, one observation is that vb plus v and vb minus v is basically 6 kilometers. Okay, it's fine. Is there any cancellation here? No, we're not able to see any calculation. This is our first equation. Okay, now we're going to make the second equation. Second equation is just simple for this raft. The total time which the boat took, to travel and meet at B point, that is 60 plus t time, 1 hour, 1 plus t. Basically the same time is for the raft to travel 6 kilometers. So making the equation for the raft, there's a raft equation. If you include, it will be just v, okay, because it's flowing with the flow of the river. It's just flowing with the flow. Okay, so v raft is equals to v of the river, that is v, which is here. I took it from here, I've assumed it initially. So v into time total was same for the boat. Okay, 1 plus motorboat, 1 plus t, that is 1 hour plus t sometime, equals to 6 kilometers. Okay, this is the second equation. Now we solve the both equations. What you want to get is that, see, if we take common this thing, you can see easily. If we take common this thing, that is v, we'll get 1 plus t. Okay, here. So this is basically 6. Okay, this is basically 6. So if we replace it here, okay, so from here we get the results. From the first equation, we know that vb, 1 minus t. If we take common vb, if we take v common from the first equation, we'll get 1 plus t. Okay, and we substitute this v1 plus t in this equation. That is from the second equation. If we substitute v1 plus t in the first equation, we'll get 6 equals to 6 vb1 minus t. This is 0, okay, and then vb1 minus t is equals to 0, and then see, vb can't be 0, okay, so just because it's a multiplying factor, so we'll conclude that 1 minus t equals to 0. We'll put 1 minus t equal to 0, so t equals to 1r. We'll get the result t equals to 1r. Why vb can be 0? Because it's a velocity of the boat, no? Because it's already written, given in the question that, you know, the assuming the duty of the engine to be constant, that means that it's having some velocity, which we assumed is as vb, which is the velocity of the motorboat. So we get t equals to 1r. So substituting it in equation 6, we get the value of v. So what will be the value of v if we assume in this equation? We'll substitute in this equation, that is t equals to 1. So it's 2v equals to 6. So we get v equals to 3, which is basically v implies that v equals to 3 km per hour. And we have initially assumed that v is basically the velocity of the river plus velocity of the raft. So here it was asked find the flow velocity, which we got equals to. So this is our final answer, v equals to 3 km per hour, which is the flow velocity of the river velocity, or you can say that raft velocity, which is same as we got from the relative concept. We can check it out. Relative concept, the answer was, for the relative concept, the answer was 3 km per hour, okay, and from the ground frame also, we get the same answer, that is 3 km per hour, okay. So next question we will solve in next slides, okay. Thank you very much.